Hello and welcome to another episode of Conic Sections. Today we're talking about hyperbolas. Hyperbolas, the word itself, is similar to an English word, hyperbole. I think hyperbole in English is like an exaggeration or something. Hyperbolas are not like that. So hyperbolas with an A at the end is kind of like a parabola. So you know how parabola is a U shape? A hyperbola is like the hyper version of that. So there's actually two of them. So it looks like this, one on each side, on the left and the right, or it could even be up and down. Like this. Okay, so these are the two different shapes that we're going to deal with. As usual, we should be able to find a center within our hyperbolas. And each of these is called a branch, in case you weren't aware, but fun fact. And then the bottom of each U is called the vertex. So then the plural version of it, just like before, would be the vertices. And then within each hyperbola, there's also a focus point, and it always goes inside the U shape. And remember, the plural of a focus point is a foci, or our foci. So when we talk about two of them at the same time, they're called the foci. Okay, so that's basically all the parts that we need to be able to graph a hyperbola. So let me show you what the standard form looks like. It's actually super similar to the ellipse. So if you think back to both our circles and our ellipses, we start with x minus h squared, y minus k squared. And just like the ellipse, this one's going to be set equal to 1. And then we got numbers on the bottom, so I'll just call it a squared and b squared, some numbers, whatever. The difference is that there's going to be a minus sign in the middle instead of plus. So ellipses we're adding, hyperbolas are subtracting. So that's the difference between the two. And then this equation here specifically goes with this one here, where the branches are on the left and the right. When it's up and down like this, the equation looks slightly different. So if you notice, I'm writing my y's first. So basically, in either form, one of the fractions is going to be a negative. So when y's are negative, because the negative sign's in front of the y's, it'll be sideways like this. And then in this form, if the x's are negative, because the negative sign is in front of the x's, then it'll be up and down like this. So that's how you'll be able to tell. Okay, so just like before, any number, so see how I don't care which one's A, which one's B. I don't care what numbers are whether A is below the X's or A's are below the Y's. Remember, just like when we were graphing the ellipses, whatever number is below the X's, that's what moves left and right. Whatever number is below the Y's, that's what moves up and down. So same thing here. If whatever number is under the Y's, that's what's going to move up and down. Under the X's, left and right. One thing you want to pay attention to when you write your center, though, is because it doesn't go like left to right anymore for the H and K, so make sure the H is the number that's next to the X's, and those always come first, because when we write coordinates of points, it's always X comma Y. So X comma Y for your center. X comma Y for your center here. Let's do an example. We'll start off nice and basic. We got x squared over 9 minus y squared over 4 equals 1. So right off the bat, we should be able to tell the center is going to be at 0, 0, because we're not adding or subtracting anything from this. And then the hyperbolas are going to go sideways like this because the negative sign is in front of the y's, like in this form, so it'll be like this one. So I'm just going to sketch that out just so I remember. Okay, and then my vertices are things that I want to be able to find, and my foci are also coordinates that I want to be able to find. Okay, so here's how we would graph it. Let me switch over to my graph paper. So if my center is at 0, 0, start off with that. Because my hyperbolas are supposed to go sideways here, this way, I need to know how far I'm moving from the center, left and right. So left and right is the number under the x's. So that's that one right there. Since there's a 9 there, square root of that means I'm moving 3 left and right. Okay, so 1, 2, 3. 1, 2, 3. Those are going to be my vertices then. So I'll just put a V next to it for now so I remember those are my vertices, because I know they're vertices because it's the sideways hyperbolas. And then I also need to know exactly how wide my little curves are going to be on this side and this side. So what we want to do is also move up and down. That's why we have the number under the y's. So it was a 4, so that means I'm moving 2 up and down. So again, from the center, move 2 up and down, like this. So this process is kind of the same as how we've been doing the ellipses, except this is right when we've got these 4 points, this is where it changes. So with these 4 points, we're going to draw a box. So wherever your 4 dots are, that's how you're going to draw a box. It's not a diamond, it's always a rectangle. So extend your lines horizontally and vertically from wherever your points are. Okay, with this box, what it does is we want to actually draw an X through the corners of the box so that we make asymptotes. So if you remember back in the day when we used to graph things with asymptotes. Asymptotes are this line that your graph is going to get really close to but never touch. So let me draw that line first. Oh my gosh, my straight line drawing skills, amazing right now. Woohoo. Okay, that's kind of close. Okay, there's that one and that one. Okay, so these are asymptotes. That means our graph is going to get really close to these lines but not actually touch it. Once we have our asymptotes drawn, then we can go ahead and draw our hyperbola, which goes like this. So remember we said start from your vertices. It's going to make that U shape right there. So this vertice, or vertex, has to be the bottom of the U then. So it'll look like this. So the way I'm drawing it is that the U has to be where the vertex is. But then as it goes outwards, it gets closer to the asymptotes. So it's going to get really close there, but not actually touch. Same thing on this side. And then we're going to do the same thing on the left. And again, it doesn't have to be a perfect graph, but that's what it should look like. So if your lines for your asymptote are like steeper like this, where they're more slanted, then your hyperbola is actually going to be wider, and so on. So that's why we need this box in the middle to help us draw our asymptotes out. So let's go back and actually identify our vertices and foci and stuff now. So we said our vertices are here and here. They were to the sides, so the coordinates of this would be 3, 0 and negative 3, 0. And then for our foci, we have a formula like we did before with our ellipses to try to figure out where the foci are. The formula looks like this. this should look familiar. C squared equals A squared plus B squared. It's just the Pythagorean theorem. So the Foci formula is just Pythagorean theorem here. So if you remember with the ellipses, this was not the same thing, because with ellipses, this was a minus sign. So we did bigger squared minus smaller squared because the order in which you subtract is important. But here, we're just adding, so it doesn't matter which one's bigger, which one's smaller. Just the two numbers at the bottom, add them together. And another way that I like to remember this is for the hyperbolas, standard form always has a minus sign here. For the foci formula, it's a plus sign. So think opposite signs. With ellipses, we had a plus sign in the middle, but then a minus sign for the foci formula. So opposites again. Keep that in mind. That's how I remember it. So in this problem, our foci, we want to figure out what C is first, because remember, C is that distance from your foci to the center. So C squared for us would be these two numbers added together, because this is A squared, this is B squared. So 9 plus 4 gives me 13. That means C is the square root of 13. So on our graph, that means we're moving from the center, and then we're moving left and right by square root of 13. We know it's going to be left and right because it's got to be inside the hyperbolas, so it wouldn't be up and down. You wouldn't move that way because your hyperbolas aren't that way. So it's got to be like somewhere in here. Square root of 13 I think ends up being like 3 point something, so that's how we know it's going to be like 3 point somethings like here. So those are our foci. I'll label those as with an F. Foci. If we were to write these out as coordinates, we would go from 0, move over to the right by square root of 13. So square root of 13, comma 0, and negative square root 13, comma 0. And there you have it. That's how we would graph a hyperbola and find its foci. So I'm going to do another example just so we're clear for the graphing part. My pen is just not good today. I don't know what's happening with it. Okay. Alright, so I switched pens. Next example, I have y minus 1 squared minus x plus 2 squared over 16 equals 1. So if you took a look at our equation, first of all, we're missing a fraction here. So if there's nothing underneath, it's kind of like we're dividing by 1. So I'm just going to add that in just so I remember it's technically a 1 there. So if you ever see like something not in a fraction form, but it's still equal to 1 already, it's probably just a 1 on the bottom. Okay, the other thing I wanted to notice here is that the minus sign is now in front of the x's. So if it's in front of the x, that means our hyperbola is going to go up and down like this. Okay, so keeping that in mind, we want to be able to identify our center, our vertices, and our foci. So our center here. Remember to pay attention to which one's the x, which one's the y. So here in front of the x we have the 2. So remember to do the opposite number. So negative 2, comma positive 1 will be our center. Okay, so since I know where the center is, I'm going to start graphing this so I can figure out where my vertices and foci are. So we said we had a center at negative 2, comma 1, which is right here. Okay, so then we want to figure out, since our vertices are going to be up and down like this, then we want to know how far are we moving up and how far are we moving down. Up and down is always under the y's, so that's here. So we are moving 1 up, 1 down. And then, just so I don't have to flip back to this, this is going to be 4 left, 4 right. One up, 1 down. So these are my vertices. And then 4 left and 4 right. So that's there. Okay, once I have my 4 points, make my box. So I just draw vertical lines from the sides and horizontal lines from my vertices. So there's my box. So now I just want to connect the corners of this box into my asymptotes. So from here to here, it's going to be a pretty wide X here. Okay, so there we go. Okay, then we know our hyperbola is going to be up and down, so it's got to go this way and this way. Okay, so we know where our vertices are. So I'm just going to make a U shape. This one's going to be super wide because look at my asymptotes. They're all the way on the side like this. So following my asymptotes then, I still get that U shape. They're just much wider of a U than we had before. Okay, so remember you're always starting your U where your vertices are, so it's never the center. There should be nothing drawn inside the box. Okay, and then so now we know where our vertices are, so that point is -2, 2 and -2, 0. Okay, last thing, foci. So we have our formula, c squared equals 1 plus 16. So just those two bottom numbers, the a squared plus b squared. That gives me 17, so c equals the square root of 17, which is like 4 point something. So in my graph here, that means my foci is gonna be, from my center, I'm gonna move 4 in a little bit. So 1, 2, 3, 4. And a little bit, and then again from the center, 1, 2, 3, 4, and a little bit. So my foci this time don't fall on like nice numbers. So remember when we write our coordinates for it, it'll look a little different. So we're moving up and down for our foci, right? So from our center, up and down would mean that our y value would change because that's up and down. So the x value was still 2, but then the y value is going to be 1, and then we added the square root of 17 to it, and we also did 1 minus the square root of 17 to get to our foci points. And there's that. Okay, so we've looked at two different graphs. The other part we also want to be able to do in this section is to be able to write equations in standard form. So they'll give you different pieces of information, but then you got to write the equations for it. Okay, so first, we'll start off nice and easy. Let's say we had 9x squared minus 16y squared equals 144. So this one's pretty straightforward. We have x squareds and y squareds in it, and we have a minus sign. Remember, for a hyperbola, we want it equal to 1, so the best bet would just be divide everything by 144. So if I do that, I'm going to get 1 on the right, but then I want to reduce my fractions here. So 9 over 144, I think I can divide everything by 9, which will leave me with 16. And then I'm going to do the same thing on this one. So the 16y squared over 144, I can reduce to get 9. So there it is, standard form. We'd be able to do everything else with it now. Okay, so let's say what if we had an equation that wasn't so nice, where we had x squareds, y squareds, and x's and y's all mixed in together. So our process is going to be just like the ellipses. You want to move your number over to the other side, group your x's and y's together. So here we go. I'm going to have 4x squared plus 24x, and leave a space there, minus y squared plus 4y, and then I'm going to add 4 to both sides. So at this point, remember we're trying to complete the square in order to make it look like the standard form. So before I can complete the square though, I have to make sure I don't have any numbers in front of the x squared and the y squared. So I have a 4 in front of the x squared, which means I'm going to have to factor that out. I have a minus sign in front of the y squared, so I also have to factor out a -1 then. So doing so will give me this. So keep in mind, when you factor out a -1, that also changes the sign of the plus 4y. So that'll become minus 4y. The way you want to check your work is if you distributed this back out, do you get what you started with originally? That's how you want to check. So from here, we want to complete our squares. So here, remember b over 2 squared. So 6 over 2 is 3, square is 9. Here, our b is -4, so -4 divided by 2 is -2, square is 4. And then remember, whatever you add to one side, you have to add to the other side as well. And because here we factored stuff out, so that means we have to multiply before we add to the other side. So from the x's, we're actually adding a 36, because 4 times 9 is 36. And then for the y's, we are actually subtracting 4, because -1 times 4 is actually -4. Okay, so I added the 36 and subtracted 4 on this side to end up with 36, and then I rewrote each of my completing the squares as its square. So remember, this number is just b divided by 2. So these numbers divided by 2 will get me that. And then lastly, I just want to make sure that my standard form is equal to 1. So I'm going to divide everything by 36. I end up with that, but then I want to make sure I reduce my fractions as much as possible. So 4 over 36 reduces to 1 over 9. So this will end up being x plus 3 squared over 9 minus 1 over 36 is already fully reduced. So it'll be y minus 2 squared over 36 equals 1. And there's my standard form. Cool. Okay, so I want to do another example where this time, instead of giving you an equation, I've given you that the foci are at these 2 points and the vertices are at these 2 points. Anytime they give you coordinates for your foci, vertices, anything like that, my biggest strategy is just to sketch it out, because once you sketch it out, you can kind of see like which way does the hyperbola go and so on. So our foci is supposed to be at 4, 0, and -4, 0. And my vertices are at 3, 0, and -3, 0. So just knowing that, that means that my vertices, since they are on the left and the right, that means my hyperbola should go sideways. So I should have left and right, which means that it should be in the form x minus h squared minus y minus k squared. Because if it's sideways, the x's have to come first, where the y's are negative. Okay, so then knowing that, and they also told me my foci are on the edges here, so that matches up. First, I want to be able to find my center. So if you want, you can find the midpoint of your foci or the midpoint of your vertices. That should find your center. Looking at your graph, you should be able to tell it's right in the middle at 0, 0. So I already know on top it's going to be just x squared and y squared. So now I just need to figure out what numbers go on the bottom. Well, to get to my vertices, I know I had to move from my center of 0, 0, I had to move 3. And since I know that was to the right and to the left, then that means that has to go under the x's. So since I was moving 3, squaring that would give me 9. Okay, and I know my equation is equal to 1. I just need to figure out this number here. Well, they told me the foci. So remember the foci, the distance from your center to the foci, that's c. So we know in this problem, c equals 4. So if I know c equals 4, I should be able to use the Foci formula, where c squared equals a squared plus b squared. So if c is 4, that means c squared is 16. I also know a squared is 9. So I just need to figure out what b squared is. So if I subtract 9 on both sides, I get b squared equals 7. I'm not even going to bother square rooting it because I know that's the number that has to go underneath my equation. There it is. There's my standard form of a hyperbola. Okay, I want to do one more example with you, this time where... Okay, so in this example, we got slightly more complicated numbers here. I got my foci at 10 plus or minus square root of 130. So remember, plus or minus, that just means that there's one at 10 plus 1 square root of 130, comma 2, and 10 minus square root of 130, comma 2. And then my vertices are at 19, comma 2, and 1, comma 2. So first thing I'm going to do is just sketch it out. My vertices is at 19, comma 2. I'm going to pretend this is 19, comma 2, 1, comma 2. So these are my vertices. So just knowing that, since my vertices are on the left and the right, then I know my hyperbola is going to be sideways again. So it'll go this way from my vertex. Oh gosh, my drawing is amazing. And then my foci, since my hyperbolas goes that way, I know my foci, because these aren't nice numbers, this 10 plus or minus square root of 130, it's not nice numbers, so I'm just going to kind of sketch it in. It's supposed to be there. Cool. All right, so we know it goes sideways like this, so that means it's going to be x minus h squared, y minus k squared. Since it's sideways, then y's have to be negative. And then I just need to figure out my center. So if these 2 points, if the center is supposed to be in between these 2 points, I can just count towards it. I didn't graph it really well though, so it's going to be hard to count. I'm going to use the midpoint formula to figure out the center. So the midpoint formula, I just average my x's, so 19 plus 1, and then divided by 2, and then average my y's. So that gives me 20 divided by 2 is 10. And 4 divided by 2 is 2. So that'll be my center. So I know it's going to be x minus 10 squared, y minus 2 squared. And then from my center at 10, comma 2, then I need to figure out how far did I move left and right to get to my vertices, because that'll be my a squared, the number under the x's, because I'm moving left and right. So from 10 to 19, that looks like I moved 9. So squaring that, I get 81. And then same thing as before, I just need to figure out my b squared, so then I can use my focus to figure out what b squared is going to be. So here, I know I started with a center of 10, comma 2. I need to know how far I moved from my center to get to my focus. So the coordinates for my focus were at 10 plus or minus square root of 130. So the 10 came from my center number of 10. So that means this should be how far I moved left and right in order to get to my focus. So that should tell me c equals the square root of 130. Okay, so then using my foci formula, c squared would be 130, because squaring the square root of 130 should give me 130. And then I know a squared was 81. So subtracting that, I get b squared equals 49. And then that's it. Okay, that should be it. Again, if you have any questions, you want to ask me anything, make sure you come to my office hours on Microsoft Teams between 8 to 11 every day. I'd be happy to help you. Otherwise, I'd kind of just sit around and wait for people to talk to me. Okay, guys, have a good week.